For the screencast of chapter 21, I have chosen a problem from a book where you can see two straight wires are carrying the conventional current I are connected by a 3/4 circular arc of radius r1 and 1/4 circular arc of radius r2, and it says that an electrode is moving with speed v through the center C of the arc. At instant, the net and magnetic force on the electron is 0. So it says to find the direction of magnetic field at center C due to the current I. So what I did was I used the right hand rule where I pointed the thumb in the direction of current flow and the finger called in magnetic field, giving the direction of magnetic field into the page. So the magnetic field can be added up to give the resultant magnetic field, which is also into the page, and this can be rated by the equation B net equals B1 plus B2. So the next problem asks us to find the direction of electric field at center C. So this is a 3D axis, and if we consider if the electron is moving on y-axis and the magnetic field is into the page that is along the same y direction, so the direction of electric field can be get as V into B, which is along the G direction. So the next question asks us to find the magnitude and magnitude of the magnetic field at C due to the current. And so if we use the Biot-Savart law, the magnetic field due to any piece of loop at center of the loop can be given by B equals mu naught by 4 pi I delta L into R divided by R square on the loop. And we know that on the loop the DL is perpendicular to R, so delta L into R equals delta L R unit R and sine 90, which comes out to be delta L. So the magnetic field due to any piece of loop at observation location can be given by this new equation, which is delta B equals mu naught by 4 pi I delta L by R square. So now the B loop at center we can get it from the integration, that is 0 to 2 pi and of mu naught I delta L by 4 pi R square. So now doing the simple integration, the equation comes out to be mu naught by 4 pi I 2 pi R. So if you consider if there are n terms, then the B gonna be n times multiply this equation. So now for n, where n equals 3 by 4th, the B1 comes out to be 3 by 8 mu naught I by R, and for it's 1 by 4th, it comes out to be mu naught I by 8 R2. So what I did next was like just summed up the B net B1 plus B2, and we already have the value for B1 and B2, so I just plugged in and just taking the common, it comes out with 3 mu naught I by 8 bracket 1 by R1 plus 1 by R2. And so lastly it asks us the magnitude of electric field at C. If we consider E is at the center of arc such that the net force on the electron at that instant is 0 and the electric force and magnetic fields are balanced, and what we can say is that the force due to E and force due to B are equal. So just putting the formula E small e and capital E equals E V B net. The E get cancelled out, so the E comes out to be V B net, and we already calculate the B net from here, which we just plugged in here. So the magnitude of the electric field at C comes out to be V 3 mu naught I upon 8 bracket 1 by R1 plus 1 by R2. This is a really cool problem which shows you to get the direction and magnitude of both electric field and magnetic field at center C.